Today's lesson is Chapter 6, Lesson 2 from your workbooks, and it is determining if two polygons are similar. Now, the learning intentions, or what you're expected to know by the end of this section, is first, you'll be able to identify if two polygons are similar or not. So given two, are they similar? Second, you'll be able to use scale factor to determine the size of, sorry, typo here, a second figure. So if you have one figure and they give you a scale factor like on a map, maybe 1 unit is equal to 5,000 units in real life, you'll be able to calculate the size of the second object. And 3, to be able to calculate the scale factor of two similar figures. So if I gave you two figures that were similar, can you say what the scale factor is, or how many times bigger the one is, or how are they related in size? Before we start, let's look at what similarity is again from last day. So review. Two figures are similar. So this is the mathematical definition of similar. If their corresponding angles are equal and their corresponding sides are all proportional. So the sides would have to have the same proportions. If this one here was twice as big as this one, then these two, this one would have to be twice as big as this one. They would have to have the exact same proportion in size differences. Or their angles would have to be the same, 90, 90, 90, 90. 90, 90, 99. They would have to be the same. Or if this one was 100, this would have to be 100. This was 70, this would have to be 70. They would have to be the same. So let's look at two things first. So example, your perfect test, you got a perfect score. Parents are so proud they're going to make a gigantic copy of your test and wave it around. Fly it behind a plane, something. So with your perfect test, it was done on 8-inch by 11-inch paper, a standard piece of paper. It might actually be 8.5 by 11, but we'll say 8 by 11 for simplicity's sake. And it's going to be blown up and enlarged to the size of 16 feet by 23 feet. Is the enlarged image similar to the original? It may look similar, but is it mathematically similar? To know if two things are similar, they have to carry the same proportion. So, let's do this. I'm going to compare, let's see, I have my 8 by 11 sheet of paper, and it's getting blown up to a gigantic 16 feet by 23 feet. Now, if they're similar, they'll carry the same proportions. So, now I'm going to grab a calculator. The first one, let's look at the top. 16 divided by 8. 16 divided by 8 is 2. Now, we should get the exact same proportion for the other side. 23 divided by 11 is 2.09. So the tops are proportion, it's doubled. The bottom, though, is 2.09 times bigger. So because the proportions are different, okay, these proportions are different, we would say they are not similar. All sides would have to have the same proportion to be called mathematically similar. Now the next one, are these two shapes here similar? So same thing, we need to compare all the sides. So top to top, side to side, and because these are 90 degrees, we know that if this side's 18, this side's 18. Top 7.5, bottom 7.5. So let's see their proportions. 7.5 and 5. 7.5 divided by 5 is 1.5. Okay, now let's compare the sides. This side divided by this side, 18. Divided by 12 equals 1.5. So these have the same proportions. It's 1.5 times bigger, so these are mathematically similar. So that's how you're going to tell with learning intention 1 whether two things are similar or not. The last one again, maybe just throw this in really quickly. If I had a shape that looked like this, and then I had a smaller version of it, the angles must also be the exact same. So if I knew this angle was 130, this angle would need to be 130. If I knew that this angle was 110, this would have to be 110. So top left 130, top left 130, top right 110, top right 110. The bottom right, if it was 70, the bottom right would have to be 70. So they have to be identical corresponding angles also to be similar. So that's the second way. I just threw that in because quickly I had only shown sides. So now let's look at scale factor. So first the definition. The ratio of the lengths, so the ratio, how the lengths are related, is it twice as big, 3 times as big? So the ratio of the lengths of two corresponding sides, so these two sides are corresponding, the bottoms are corresponding, the top rights are corresponding, of two similar figures, so I'm going to tell you these are similar now. So if these are similar, and they are, then their corresponding sides, these two or these two, then the ratios of those is its scale factor, how many times bigger one is than the other. So in this example, to find the scale factor, you simply, if you're told it's similar, or you've proven it's similar, to find the scale factors, you just simply have to divide them. So 16 divided by 7 equals 2.2857, and there's some more decimals. So the scale factor is, this one is 2.2857 times larger than this one. So scale factor is just how much bigger it is. Okay. It can also be how much smaller it is. For example, we'd be going back this way. But make sure the scale factor is just how the corresponding sides' lengths are related. Now let's look at two examples of scale factor. First, a map scale factor is given as 2 centimeters equals 25 kilometers. So you have a map, and in the corner it says every 2 centimeters on the map is 25 real-life kilometers. What would the distance be if the map measured 6 centimeters between Fort St. John and Dawson Creek? So on your map, you have Fort St. John, you have Dawson Creek, and it measures 6 centimeters away from each other. So you bring your ruler out on the map. You want to know how far they really are apart. So all of that ratios and related rates work we did in the first couple chapters applies here too. We know that our scale factor is 2 centimeters equals 25 kilometers. Then to solve this, so map on top, real life on the bottom, 2 centimeters on the map is 25 kilometers in real life. The map measured 6 centimeters. So if map's on top, map stays on top, how far is it in real life? And now you can cross multiply or use your fish technique, and you will get 6 times 25 divided by 2 equals 75 kilometers apart. So to use scale factor, when it gives you a scale factor, set it up as a related rates problem. Next, how long would the distance on the map be if the real life distance was 380 kilometers? So you know Fort St. John is 380 kilometers from somewhere. How long would that be on the map? Well, use your map scale. Your map scale is 2 centimeters equals 25 kilometers. Now this question is giving us real life distance. Real life distance is on the bottom. And we want to know how big it is on the map. So again, you can cross multiply, use your fish technique, however you're going to do this. And I get 380 times 2 divided by 25 equals, my map is going to be from wherever I wanted to know, Fort St. John to 380 kilometers away, on the map would be 30.4 centimeters on the map. Okay, last thing we're looking at today is calculating scale factor. So what if we want to know how many times bigger something was? So to calculate scale factor, you need to divide corresponding sides or values. So in this example, a replica toy car, you have a little toy car, and it's replica, so it's made to be exactly similar, is 5 centimeters long. The real life car is 6 meters long. What is the scale factor? So I guess you could do like a map and say, well, 5 centimeters equals 6 meters, and say that's our scale factor. But that's not really what we're looking for. What we're looking for is how many times bigger it is. So to compare, you need to compare the units. So 5 centimeters and 6 meters, they're in different units. So you need to use your formula sheet and know that every meter is 100 centimeters. So if I times this by 100, then 5 centimeters equals 600 centimeters. That is, I guess they're not equal to each other, but what we're saying is this is how they're relating to each other. So now that they're the same units, I can divide. 600 divided by 5 is 120. So it is, the real one is 120 times bigger, or 1 unit on the toy car is 120 units on the big car. So first, to get a scale factor, you're going to need to get the same units, so centimeters to centimeters, and then you can simply divide them. Okay. Your assignment, you're going to work through section 6.2 of your workbook until you get to 6.3, then you can go on to the next video. Good luck. If you have questions, come see me. Stay classy, Math Pass.